Okay, hello everybody, good morning. Hope all of you are doing well and welcome to machine learning class. So as you know, this semester we will have one of other interesting course, machine learning. Machine learning is more general in comparison to specifying in one specific field, for example, deep learning, for example, reinforcement learning, specific task of supervised learning and unsupervised learning. However, we will try to connect all these together to have general understanding of how machine can learn. So we will try to learn different algorithms during course and try connect them together and try to introduce you the most advanced algorithms later on in the course that currently what is happening. Today I will have a brief introduction of different techniques that we have and some of the advances that has happened in last decade. Then we continue one by one to talking about each one of those techniques. So I think majority of class knows me, but for the rest I will have a discussion how the course is going and what we will see in this semester. So if we want to have a look at the outline, first we have introduction to machine learning, that is today's course and its applications. And thank you for the technology that we have nowadays. You are familiar with many of the applications you've seen, you may hear, but we will try to go more in depth of what is happening in background. We will talk about the statistical learning because of understanding what is happening in underlying of the machine learning. We will discuss it well, why we need to even start with machine learning, with statistical learning. We will talk about later on linear regression. We will see what does it mean in machine learning and how we can use it for prediction tasks. We will talk about specifically for different classification and clustering algorithms. We will see from the most basic techniques and we will try to cover the most advanced techniques that nowadays we can use classification and clustering algorithms. We have one of the very famous algorithms, support vector machine, that we need to see what it is and how it is working. Of course, in machine learning, we have neural network and convolutional neural networks, CNNs. As I know, you have a specific course for this. Because of that, I will not stuck here too much time. I will try to just introduce for who doesn't have this course, and also last semester we discussed it a little bit in reinforcement learning class. But anyway, we will go through basics, but we won't dedicate most of the time for the neural networks. On the other hand, we have the recurrent neural networks, that is other kind of convolutional neural networks, and we will see how it is working. We will introduce the deep belief networks, and we will see the application where we can use them. Most importantly, in this course, we want to also discuss about transfer learning. How are the basics? How are the requirements to perform transfer learning between different networks and between different applications. I also introduce ensemble learning techniques. We will see how we can use different training and different models of techniques together to engage to solve one single problem, and how much advantage we will achieve with having ensemble learning techniques. Then I will go through multitask learning, and multitask learning is also another interesting and one of the hottest topics that we can see how machine learning can use these techniques to solve problems. And finally, we will go through the state-of-the-art technique of the machine learning. What does it mean? It means that last 2 years, 3 years, we have a couple of new algorithms, for example, in image processing, for example, in robotics, in different fields that we have. We will see based on what we learned, what they've done. So that this gives you motivation based on what we learn in class, how they think, and how they bring ideas to applications and solve problems and even publish high-quality papers or do nice research in industry or use it for real environment to make it work. We will see some examples here as much as we have time. So any question for this part? Is everything clear? Okay, good. Some of you may have some background about some of these, and that's nice. Then you can understand that part easier and connect to the other parts, and especially at the end that we will start to learning state-of-the-art algorithms, it will be quite easy for you to get the idea. So as you know, same as last semester, we have assignments and homework that will cover your 30% of marks. So depends on the slides that we have and depends on the course. Not at the beginning parts, but usually we have every week one assignment up to next week or 2 weeks time. You need to finish it and upload it to Moodle. Then we have project. The project will be related to your assignments, homeworks, and the slides. Then you need to do some implementation on some tasks that you desire. Usually I don't limit the students for specific tasks that I assign them. Usually you will have option to choose among what you are interested in and what you can work. Then discuss it with me, then will be your project. We have only 15% of mark for midterm, and exam will be 25% of your exam. As you see, majority of part is based on the research and the implementations and study that you do yourself during course. So the rest won't be too much pressure for you. Here again, any question? So for who doesn't know, we are using Moodle, and all the classes slides will be there, and all the assignments will be there. You should check it and upload it, everything over there, and that's my email if you need it to contact me. And my office is next to the class currently. I may change to the other building, but for now I'm over here. So, any question over there? Is everything clear? Okay, good. So, for machine learning, we have too many good books that they are very clear. But the two of them that I prefer, first of all, is an introduction to statistical learning from Gareth James. That is very nice to understanding the basics of the statistical learning as introduction to machine learning. Then in second edition, they also introduced and discussed all the deep learning and all the advanced techniques that currently are existing, and very nice to get the basic ideas. Second book is Introduction to Machine Learning itself, third edition from Ethem Alpidin, that you can see what is the machine learning and what's the basics and what are the things that you need to understand to solve really big problems. So, as you know, nowadays we have lots of programming languages that we can use for different tasks. And especially for machine learning too, we are not limited to one single programming language. But here we prefer Python. And for Python, we have different IDEs, as you know. Again, I prefer myself Visual Studio Code. This VS Code is I used it at the time that no one even knew that is existing. Like long time ago, it was not famous. But luckily, it's very famous now, and you can use it. You can use PyCharm, you can use Notepad++ and Jupyter Notebook, depending on you. But as I told you, we prefer in this class VS Code and Python. On the other hand, you may work with Anaconda to install and have the old libraries. We prefer to install the libraries that we need ourselves into Python. But if you install Anaconda, of course, you have most of them ready for you. And this is like Anaconda is mostly useful for data science and since we want to discuss, we are not limited only for data science, we prefer to install whatever we want ourselves. But if you want to use, that's okay. On the other hand, let me introduce Kaggle. I don't know have you heard about that or not. You have online science projects and machine learning projects in Kaggle, and there are usually competitions and there are usually prizes for the winners. So what is happening? There are some problems in the world. They state it there. They even publish the data set. They say this is the data set and this is the problem that we have. Then, like you have 1 month. You can go check the website today to see what are the projects and what are the challenges there. Then you have 1 month, 2 months, 3 months. Then you work on the project and everybody publish their code over there. And the performance, who achieves the best performance, the winner, then gets the prize. The first, second, third. And this is very nice understanding for yourself also to understand, okay, how good you are, how your ideas are good. And the novelty of your work is like if you are better than everybody else, you even win over there. So after studying machine learning or during course, you even can consider to go to Kaggle, study it, and try to participate there. So we may also discuss some of the challenges over there later. But what we want to talk today in chapter 1, so first of all, we will talk about the introduction to machine learning quickly. Then we will talk about the history of machine learning. I want to explain what has happened in the history of machine learning. Then we will discuss general understanding of supervised, unsupervised, and reinforcement learning techniques. Then we talk about the semi-supervised algorithms definition, how they are, and what are the differences between, for example, supervised, unsupervised, and semi-supervised learning. And I also discuss today about the latest general advances of the machine learning. And in this chapter, you need to know general concept of machine learning plus the applications. So if you want to have a look at the history, so we can say everything started with artificial intelligence. That, you know, is one of the most famous and major field of study, that is AI. And it started, initiated in 1950s and continued. So we can say like up to 1970s, it was like only a field that everybody knew, and we knew that, okay, artificial intelligence algorithms like search strategies, techniques. I don't know, have you passed any course like named artificial intelligence? We have blind search techniques, and we have informed search techniques that for example, A-star, and many branches of A-star techniques that in the static space try to intelligently search about the possible solutions. And they are also efficient nowadays. They are also working in different applications that still can be discussed very well. On the other hand, we have machine learning. That machine learning is on top of the like under artificial intelligence, and the machine learning covers like sub field of AI, and it started in the 1980s and continued most importantly up to 2009. That up to 2009, like it was known as like only field that we are continuing. Up to then that also deep learning arrived 2010, and as you know, still we continue its development. So one maybe misunderstanding sometimes is happening when we see this deep learning. We think that, okay, these are already finished and we continue deep learning. Although it is one of the toughest and hottest topics that everybody researching on it, But still, machine learning techniques and AI techniques are developing and they are ongoing. It's not like these two are stopped and only deep learning is continuing their development. But of course, it's one of the major technology that is continuing. So let's have a quick and simple definition of machine learning. We say machine learning is a type of artificial intelligence that allows prediction outcome without being explicitly programmed. It means that you have a system, you don't need to write if-elses, for loops for everything. Whatever happening, you say, like for example, you have a fridge, you want to write some code for it. If the door is open, do this. If the door is closed, do that. If-elses conditions and the for loops to run everything. Here we want to have in machine learning some algorithms that make decision itself. We don't need to say every detail of what, if this happens, do this. If that happens, do this. We don't want to do that. This is whole history, whole understanding of a machine learning algorithm. Machine needs to make decisions and perform itself. So that the concept of learning comes, of course, if machine wants to do that, the machine should learn. And if we want to learn, learning from what? Learning from data. So if I want to learn, I should try something, or if machine learning wants to learn, detect a cat in the image, should learn by looking at many cats in different images and understand what is the cat and where is the cat and what, depending on what we want to do. So here we have better visualization of the artificial intelligence. So we have AI, then machine learning, then inside machine learning, if we want to open it a little bit more, let's see what we have. So one of the sub-area of the machine learning that we should understand what is happening there is supervised learning. Today we will discuss what does it mean. Supervised learning is one field. Second field, unsupervised learning. And after unsupervised learning, we have reinforcement learning. So these three elements are the major components. We have two more. One, deep learning. That deep learning sits on top of three of these. That because like last semester we discussed it very well that with reinforcement learning we had some techniques that we needed to make it more robust, make it more kind of solving memory problem. Then we introduced deep learning connected to reinforcement learning. Same here. For supervised learning, we have independent algorithms, but we can connect it to the supervised learning techniques. We will see. For unsupervised learning, the same. We can connect the deep learning to unsupervised learning. So is this all? Actually, we have one more that it is called semi-supervised learning. And semi-supervised learning is sitting on middle of the supervised and unsupervised learning. That today I will try to give a general glance of what these are. Then later on, in each chapter that we want to discuss, first introduction of that topic, then we go in detail, see algorithms, and discuss them as much as we are needed to understand. So here, if you look at the supervised learning, I stated some notes. In supervised learning, the general concept is we want to have some data that are labeled. It means that we have a machine, an algorithm that wants to learn something. But this learning in supervised learning technique is that we want to give data, but that data is specified by human what is what. For example, I say, this is cat in the picture as human to machine, and I give many of those samples to my network, to my machine learning algorithm, and it learns based on my knowledge and my help. So generally, this is called supervised learning. On the other hand, unsupervised learning, on the other chapters, I will a little bit explain it more. But the simplest thing is that we don't have labeled data anymore. We want to say, okay, let's say I don't give the labels. And machine learning technique and the algorithm that we have should learn how to solve that problem. So what about reinforcement learning? In reinforcement learning, we have agents. Agent means like you can consider a robot that interacts in the environment. We don't have the concept of supervised learning. We don't have the concept of unsupervised learning. The agent needs to interact, like move in the environment to see what is happening, throw this on the floor to see what's happening. Then for example, if there is object here, kick to see what is happening. Then learns. That also today I will have brief introduction. Of course, we won't enter to it. It is very interesting topic, but we will not enter to this because last semester I discussed it very well. And later, for next semester, I may open deep reinforcement learning that specifically talks about very advanced deep algorithms of the reinforcement learning that we have nowadays. So any questions so far? Is everything clear? Good. So in supervised learning, as I explained, we want to learning from training data set that are labeled so that the knowledge of supervisor helps the machine. On the other hand, in unsupervised learning, we want to find the structure of hidden the hidden structure of the data in the data set that we have. What does it mean? At the beginning, maybe it looks a little bit confusing. What kind of hidden structure there can be? We will have some samples. In the next slides, you will see. And reinforcement learning, as I explained to you, we want to learn from interaction. This picture is very nice picture. I usually want to show to the students because shows a general understanding of what is happening in other config. So we have the machine learning, as I explained to you, supervised learning, unsupervised learning, reinforcement learning. And we have semi-supervised learning. In this figure, we don't have it, but there is in middle of these two. But what is the interesting thing that we need to know in this picture? If you look at the supervised learning, it is divided into regression and classification. That we will discuss. What does the regression mean and what is the classification meaning is in machine learning. For example, in regression, we have estimation of the expectancy. We have population growth prediction, weather forecasting, and advertising popularity prediction of regression problems. We are not limited only for robotic tasks. We are not limited to any specific task. Anywhere that we need to predict, we can bring our algorithm and predict these as regression problem. On the other hand, we have classification problem. That for classification problem, we can like identify fraud detection, image classification. We have customer retention that says, okay, which customer, how to keep a customer with classification techniques, which one is more important for us, we will discuss later, and diagnostics, and many different applications that wherever we need to classify, split the data to different classes. For example, we have again this in next slide, cancer detection. There are a couple of images, you say this is cancer, this scan is cancer, this scan is not. Very simple understanding of the classification example for machine learning. On the other hand, so supervised learning. On the other hand, for unsupervised learning, we have, first of all, the most important point that you need to know is the clustering here. Here we had classification, but here we don't call it classification again, we call it clustering. Clustering means still we want to split the data, but not same as the classification. Because here we have labeled data, but here we don't have labeled data. Because of that, we call it clustering, and we will see exactly how it's happening. So whenever we study algorithm, you must know this algorithm is classification or clustering technique, and don't mix it up. I've seen many people who studied many courses, machine learning already, but they don't know what are the differences and they cannot distinguish it. So clustering, classification. In unsupervised learning, also we have dimension reduction. Very interesting and important task nowadays. I will introduce some techniques that when, for example, I have a robot that looks at this environment, very complex for a robot to understand it. So if I can reduce the dimension, that is more understandable for my robot. All advanced algorithms that nowadays we have is working like that. Reducing the dimension first and do the task later. Then reinforcement learning, that we have real-time decisions, robot navigations, learning tasks, skill acquisition, and the game AI, and many other interesting tasks that we can have. And these are three classes of the techniques. And as I told you, we have semi-supervised learning that is in middle of these two. And today I will have an introduction for that too. So before continuing, we want to see what are the key moments in machine learning. What are like kind of course, many things has happened during the development of different algorithms in machine learning, but we want to have some of the samples of the key moments that we have. In 1950s, we have the perceptron algorithm, and it works in artificial neural network, you know. We will quickly have a look later on. Then in 1980s, we have backpropagation algorithm that helps us to train this artificial neural network with backpropagating the weights of the network in neural network. If you are familiar, you already know exactly. If you are not, no worry. We will later discuss it quickly. What does it mean? No worries, because I know the class usually is unbalanced. Somebody doesn't know anything, somebody knows all of those, and this is repetitive too much. So anyway, we will go in midline to make sure that everybody learns from class, not missing anything and not too hard. So we have in 1990s, one of the very important algorithms, support vector machine, very popular for classification tasks. And now when I say classification, you should think which class it is. Supervised, unsupervised, you should quickly understand. Later, if I ask if this algorithm is clustering or classification, what branch it is, then you should say, okay, this is clustering or classification. Then 2010s, we have deep learning, that very interesting tasks like image recognition, speech recognition, and NLP, natural language processing. And recent years, the deep growth of the reinforcement learning tasks. Of course, we are not limited to these 5. There are other important points too, but these are the most breakthrough ones. We have a nice example here. 2011 from IBM, Watson introduced Jeopardy play. So that they introduced deep QA. Deep QA, don't mix it up with deep Q learning or something. This is deep question and answering. That is based on these items that you can see here. Uses NLP, uses information retrieval, uses machine learning techniques, knowledge representation, and reasoning to do what? To answer the questions, and even go to competition and compete against the best players. So that we can see the video. I just try to be silent so that you can hear.
I remember that morning going to the lab, and I was thinking, this is it. This is the last Jeopardy game. This is Jeopardy, the IBM Cabinet. Brad, if you're ready, pick your first choice. Let's take alternate meanings for 200, Alex. is executor, right? Same category, 1600. Answer. That was the moment when I knew it's over. The category is 19th century novelists. What Watson wants to do then is preserve the lead, not take a big risk, especially with Final Jeopardy, because just like for humans, Final Jeopardy is hard for Watson. Now we come to Watson, who is last. Hello, 17,973, and a two-day total of 77,147. I would have thought 5 years years away, but it's here now. I have the bruised ego to prove it. My past Jeopardy experiences have been great. We weren't really weighted with this kind of technological, philosophical importance. I think we saw something important too.
Didn't really think very much about the implications until later and say, wow, wait a second, this is history.
Of course, this whole project is not ultimately about playing Jeopardy. It's about doing research and deep analytics and a natural language understanding. This is about taking the technology and applying it to solve problems people really care about. We're just so excited about all the things we can do with it. I had thought this is the end. We'll get there, we're done. And I'm realizing it's just the beginning.
So as you can see, one of the very interesting applications, and really Watson played in against the human and the best of humans that can answer the questions over there and find the correct question for the answer that is appearing. And this is very interesting. And this is like still 2011. We have 10, 12 years more now. And I will introduce also what is happening. On the other hand, all of you are familiar with self-driving cars. I'm sure most of you even maybe tried. So what we have there, we have object detection and recognition. We have the path planning. We have the decision making. We have the predictive maintenance. We have user behavior analysis, and we have simulation and testing. So each one of these require independent most of the time and very robust machine learning technique to be implemented. You may think, okay, do we need to do all of these with deep learning algorithms? Or all of these are relying on deep learning algorithms? So what do you think? Especially who are familiar with this. For example, for object detection and recognition. So the answer maybe is like most likely, of course, deep learning. What about the path planning? What about the decision making? What about the predictive maintenance and all the other tests? Are we limited to deep learning? What do you think? Yes or no? So you? No. What else? Who else? Is there anybody who says yes? Okay, good. So let's have a look. Let's answer it. We say, okay, although deep learning algorithms are very well, although they are very powerful and nowadays very common to use, but nowadays we still using combination of the traditional machine learning techniques with deep learning techniques. So what is happening there? We have the feature extraction usually and object segmentation, for example, with convolutional neural network. This part is neural network, deep learning. We will introduce, no worries. If you don't know what are these, I will introduce in this course. What is the convolutional neural network? What is the object segmentation? And what is the feature extraction? So these come in combination to solve real application problems. For example, we say also in addition to deep learning, we have decision trees, support vector machines that we will see. What is it? We will have also the random forest technique, that how these techniques can use and can combine with deep learning techniques to solve problems. So that even nowadays, the companies that we have for self-driving cars, they are using the combination of algorithms. If you go check each independent of these companies for self-driving cars, the most famous ones, for example, Tesla, Cruise, Uber ATG, and etc. All of these are stated that we are using not only deep learning, but also, for example, feature extraction techniques by experts to make our algorithm robust to be working in real environment. Okay, any question? So, for example, as research for yourself, you should be now interested in, when I go back home, let's go see, for example, how Tesla, how Cruise, which algorithms are combined with which one in their technique. Then you can have better understanding in this course later when I'm talking about, for example, random forest or SVM or feature extraction. You say, oh, this is that one that they used, I know. And this is how you learn the courses in class. So if I want to talk about another stunning application, so we discussed 1, 2, and this is third stunning application of machine learning. That is NLP. I think most of you have heard and or maybe tried it. So it's ChatGPT, one of them, as a chatbot that is chat generative pre-trained transformer. That is this one is proposed by OpenAI, 2022, is very recent, and it is generating human-like responses. Not, of course, very perfect, but very interesting questions you can ask, and they also answer very interesting. The machine answers you very interestingly, and what they've done in background, they've used supervised and reinforcement learning, the algorithm that we last semester studied, PPO technique, to combine to answer the questions that we have from this chatbot. Besides that, they are using transfer learning, that we will see why and how important it is that they are using as one of the advances, the most recent advances in machine learning techniques that we have. So are we like have only ChatGPT? Of course, no. We have like Bert from Google. We have the Roberta from Facebook. We have T5 from, again, Google. We have XLNet from Mellon University and Google together. And we have like 2 other techniques and a couple of more. These are the most famous ones. I think also Bing recently released in some countries the chatbot that you can start to interact with the AI. So if one of your professors asks you to go write some document and you use this, so what happens? You think maybe it's untrackable, but it is trackable, because there are some other ChatGPTs that they are in charge to understand if you use the AI or not. So be careful about that. Don't rely on this, but for learning things is nice and of course under development. So by looking at these just few stunning applications, there are many, but we just wanted to have a general look. We say, okay, let's a little bit talk about details of machine learning and open it a little bit more and discuss the topics that I introduced you today. What we have in machine learning generally, we say we have input that in supervised learning, the data are labeled, that we can say, okay, this is the X, my data. So this data can be multidimensional or whatever. It can be a picture or it can be a real value. So whatever data is, I have a label for that. And I have set up these data and labels. That is my input. Looks like any common neural network or deep learning or many algorithms. But here we have label per each data that I have. And this can be millions of data. This can be only 10. And we will discuss when we use what kind of algorithms we need to use if we have less data, if we have more, what we need to do. On the other hand, we have the objective. What is the objective? The objective is good approximation for predicting new data. It means that if I have another data that is new, we don't have it in this set. So, for example, xn is come, that xn has no label anymore. Then my Supervised learning technique guesses the label. The label can be weather prediction, weather can be the price prediction, whether the sample output can be robot action, can be anything that we need to predict over here. That we formally write it in this form, f of the x that we want to get the y as output. This is the very simple understanding of what is happening. In supervised learning, if you want to visualize what we discussed, we have label data. You can see, for example, different data here, triangle, circle, for example, teardrop, that we have the training model. In training model, we want to say, okay, my model understand that this is circle. My model understand that this is triangle. Then, of course, I need to calculate loss, because this is a loop of iteration that my model is not able to learn it like in one moment. It's taking some time with practices, and with loop it learns. And of course, I need to calculate loss. We will discuss what does it mean. Loss means that what is the error of the my learning. So, for example, if I have high error or high loss, it means that my model haven't learned this. Randomly says, if the model randomly says what are these, so loss is very bad. Loss is good if it can detect the labeled data very well. After training, what is happening? I have test data that may be seen, may be not seen. Then we have prediction. This test data will be predicted by model. If they are correct, so it was successfully done on my supervised learning. Otherwise, it is not. This is the visualization of what is happening over there. So if you want to understand, for example, price prediction, very standard example for this is the home size and price estimation. What does it mean? It means that you want to buy a home. So when you want to buy a home, if this is the home size, we say, okay, of course, how big it is, the price is increasing. We have some sample data, one of the random cities in the world. We say, okay, so this is a home that with this size, the price is around here. The other home, these are the samples that I have from one city. Then, what I want to do in supervised learning, I want to have a prediction. Different kinds of algorithm that from next lesson we will start to discuss. For example, how we can generate this line in simplest form with regression. Then we will bring it to much more advanced, push it to much more advanced algorithms. So I can predict this line. When I predict this line, what does it mean? It means that, so I find this line that predicts the data. It means that if new data comes, this line can tell me how much is the price. What does it mean? It means that, so the input here will be the size. So you get the, for example, size can be the price too. But let's say like 150 or 52 comes as input to my model. Then what can I say? My prediction from this line, if I continue the intercept, my prediction will be somewhere around here, a little bit lower than 1,000. For example, can be $1 million or something, very expensive. So, but really the data is, the real price is over here. A little bit of error, but still I can predict. It's still based on this size input. I can say something. My model says, okay, something nearby, what is the price? You just say like this size of home, that size of home, this size of home. It can say approximately the price will be estimated like that. And how much your model is more accurate, you can estimate it more accurate over there. On the other hand, if you give the price, you maybe want the size. I have this amount of money, how big home I can buy? Then the model says, no, you cannot buy anything, for example. We have second example of spam detection. So you every day getting emails are going to spam or not spam. How this is happening? Of course, there is a machine learning algorithm running in background in the server that each email that comes detects that it should be going to spam or not spam. You can write, after learning machine learning, your own code. What are the important features that machine learning can understand? What is the email? The sender also can be one feature that machine learning technique can understand what is, if it's spam or not. The time of sending, the contents of the email that is coming to you, the header of the email that is coming to you. For example, if header is like trying to attract you with money, price, or you want something, or those kind of things, most likely will be spam, for example. No one gives free money to anybody. So don't believe it. Of course, then machine learning should learn it. Symbols used in the email. If there are $sign, for example, or some symbols that again wants to attract you, they can be considered as spam. The links that is existing over there. So my model can go check the link. What are the details there? Is it advertisement or it is like a university email? That is that if my model can learn the links differences, then I can understand and have higher accuracy on spam detection. Attachment format. So no one sends you exe file, right? PDF is okay maybe. So but some uncommon formats should not come with email unless it's like that person is in your list or something, and etc. So we want to see how machine learning techniques in different forms can learn these kind of things. As I mentioned, cancer detection is very crucial and very helpful for society and the health. What are the input? Scan image, and the output is kind of says that you have cancer, you don't have, or some of your cells are suspicious to be cancer or abnormal. So machine learning techniques are doing very well nowadays in this field of area, that even they are doing better than the professional doctors. So what is happening there? We have kind of inputs. As I mentioned already, inputs can go to two directions. One is like image passing and deep learning techniques. Other branch can go feature extraction and machine learning algorithm. Finally, we have prediction of if it's cancer or not, or abnormal. So who can answer when the data usually goes to up and data comes to down? Now I'm expecting some answer from you. No idea? You should have some idea. When like we have input, then traditional technique of machine learning that we will study, or the deep learning techniques, when data should go up, when data should come down, or which one we should use when? Oh, I thought all of you knowing this. No answer? Ugo, no answer? So when data should go here for up, for classification and normal algorithms that we have in traditional algorithms that we have in machine learning, when it goes to deep learning techniques, which one we should decide how.
Texture data will go for machine learning, and other than texture data will go for
Label? No.
No, the format, data format.
No. Doesn't matter. Format is not effective. Number of?
The size of your data set.
Yeah, the size of your data set. Here, in this course, you must understand it very well. That we will see if the size of data set that you have hundreds of thousands of data that are labeled, then we can use deep learning algorithms easily. But if you have limited number of data, you have 100 images, 500 images, can you use deep learning to do that? Almost no, at least nowadays. In some specific applications, I will introduce, for example, we have some deep learning algorithms that they are very hard to research also. They're trying to have one-shot learning and one-shot detection. But if you have limited number of data, you should go toward feature extraction and the algorithms that we will see for classification. And this is very common in medical applications. How many people have cancer? Most of them, they don't allow to publish data on data sets. We have very limited data for image data and analysis of the, for example, cancer or diseases. That's a huge problem. And there are some solutions that we will introduce in class also, that how if we are insisting to use this technique and we have low amount of data, what to do. We will also discuss those. Any question? Good. So I stated already for you over there. So object detection, you already most definitely have seen. We have image as input and object classes and location usually as output. Oh, that's me. And this is another example. For example, this is one of the famous examples as YOLO, you look at once. And you can see that this algorithm performs two tasks together. Not only classifies and detects which object is what, but also localizes it, where it is. This is bicycle, this is person, this is car, this is traffic light. So we have algorithms that they are very real time, and you can easily launch them and detect the obstacles and objects. That we will also have a brief discussion about how these are working. Not focused on this, but we will see. We have face recognition and detection. You have in cell phones, you have in computer systems. As engineer, you must know what is happening in background. We will discuss it here. For example, you can use different existing libraries nowadays to also to run quickly. Later we discuss it. But now those were supervised learning. If you want to talk about unsupervised learning, so what is happening here? Have a look. We have unlabeled data this time. We don't say this is circle, this is triangle or whatever. Machine should find out what are the features that distinguishes this and give us some results. Is it possible? Of course it is possible. We will see the algorithms. So, for example, let's say this is your data set. Some data related to whatever, there are some data points. If you ask unsupervised learning to classify these, what is happening? For example, the unsupervised learning may kind of say, okay, these should be supposed to be in one class, these should be in one class, these should be in one class. Look at the data. As human, if I wouldn't show you that, you may even thinking something similar. And that's very nice that machine learning says maybe these are likely looking like each other. If these are like home prices, for example, it's obvious that these are expensive set class. These are like kind of some featured one that is like in this part. Cheap, but price is high. It's small, but price is high, for example. And those are another set. We will discuss, for example, very hard task here is saying and finding for unsupervised learning how many classes we have. So that how can machine learning detect it, how many classes we have, or we should say. Basically, it's very hard if we don't say how many classes. And if we say it is hard for us, we have a bunch of data, how can I, if I knew that how many classes I have, it would be easier. Even like millions of data, I don't know. So because of that, we will see that challenge later. We have marketing example for machine learning that can group the people. And for example, based on some people are addicted to buy products, then those can be in very nice classification for me, for example, if I want to sell something. So this guy is addicted to buying clothes. So I should put a lot of effort to bring him to my store, right? So these are very nice applications over there. Another example you see. We have news clustering. Every day, millions of almost news comes from different resources. So can we use this data in useful form, kind of for our advantage? Can we? So the answer is yes, we can. If we have proper machine learning technique, we can say, okay, which country is talking about what more? Which culture is talking about what more? And many things to understand about the sport, about the culture, about the health, about different topics to see what's the trend of the even human life. Very good application. Next application. Of course, as human, we doesn't know almost anything about the universe. We are like, our knowledge is near to zero if we wanna extend it to whole universe. And of course, machine learning should help us in order to do that. As unsupervised learning, we can say, okay, this is the picture of the universe, and we have lots of galaxies, stars over there. Can you understand something from here for us? Then you see that, okay, that says like our algorithm says, yeah, these are in these characteristics are similar. Because of course, I don't want to explain this, but the light that you see is not the light that only the light. The light also cross from different universes, affects by the universe that or the situation that it crosses. Nowadays, we can analyze that too. And there are some signals inside the light itself. It's not like the picture that you can see. So that tremendous data with tremendous amount of information that is coming by telescopes can be analyzed and, for example, have some classes or information retrieval with machine learning techniques. Social media analysis, you may hear about that. So what like you doing, whatever you're sharing or whatever you're typing in social media can be used to understand your connection with your friends, your connection in surrounding environment, your city situation, your country situation, and world situation. Is it real? Of course it is real. You may hear some news from US and Trump election. So that's real. I don't say like cheating is happening or something. I mean the data can be retrieved from the social media, and the advertisement based on that can affect the how people thinking and change many things. So sentiment analyzing, tracking public opinion of a topic that is discussed and trend in the world. And trend analysis specifically, identifying the topics currently are popular. The customer segmentation that says, okay, identifying target audience for marketing purposes. The influencer identification, that finding the influences of social medias that this kind of topic is influencing this subfield. Brand monitoring, you can track the brand in public sentiment to understand like how this brand is doing in where and how it's happening. Crisis management, identifying and responding for crises. Customer feedback analysis, identifying them as feedback, and user behavior analysis, understanding the interaction and finding improvement opportunity. I remember like I think more than 15 years ago, Facebook, when it was very popular, I wrote a crawler to find out, start from my friends and their friends and create a connection with that. And that was like, even for me with simple crawler, stunning. Oh my God, look at the connections. By my view always I was understanding, oh, like the classes I was understanding. Later try to develop some techniques to classify based on the age, based on the sport. Long time ago, as new field of study. And this is stunning, but also not limited to that. You can see many applications. Personalized content recommendation is one of that says, okay, this guy likes car, that guy likes motorcycle, this lady is here likes clothes, the other one likes traveling. So based on that, advertises you something. And if you look like Instagram, you want to buy something, you're thinking to buy something, that comes to your advertisement. How that is happening? You go to a store somewhere, you come out, in Instagram it says, okay, buy phone cover. So these are happening over here. And we want to see and we want to understand how and what we can do with it. So as I told you, classification in visual you can see now. So we have labels and we classify data in unsupervised learning. So here greens are showing, or the marks showing what it is, labels. But in unsupervised learning, we don't have any label, and algorithm does that for us. Which one is harder, do you think? Which one is harder? Unsupervised. Because we don't have label. This is known to be harder, more challenging. So what about semi-supervised learning? We say semi-supervised learning is a mixture of the supervised and unsupervised. What does it mean? It means that sometimes you have labeled data, but it's not enough. You have 1 million data set. For 1,000 of that, you have label. But for the rest, you don't have label. Then what to do? You can use then semi-supervised learning algorithms approaches. So that what you do, you want to write an approach that guesses the data that doesn't have or don't have the label. Then guess the other data sets information labels. So that's called semi-supervised. That combines two techniques and useful for self-training that we also needed to annotate the data. So you can see the small portion of labeled data here and large data set, then model will train based on that. In addition to semi-supervised learning, as I mentioned, we have reinforcement learning. Many of you guys are now familiar with it. We have agent that interacts in the environment, initial from some state, and tries to do something stupid, wrong at the beginning, and learn from it. So that we don't have label or we don't have data anymore. Your agent in online form tries to learn. So the applications are starting from like resource allocation in operating system and can continue for any robotics application like helicopter or dual arm robots, industrial robot, or the different algorithms and prediction techniques. So what we have there, learning by trial and error, and it's from, the idea comes from animal learning or kid learning. So you are a kid, you do something wrong, you cut your hand with knife, you understand that knife is dangerous. You should not do this action. You touch something hot, your hand burns, then you understand you don't do that. So the same idea comes to reinforcement learning, and the agent learns from interacting in the environment. So that it started from 1980, and it has three concurrent threads that continued. First is learning by trial and error, second is optimal control, and third is temporal differences. I'm not going to explain this in details now, but the temporal differences is very important. That says, okay, how much I learn now as agent, after some time I do something else, new action comes, how much I learn now. So I compare the action that I learned, and I compare the reward that I'm getting feedback as environment. Then based on that, we can say, okay, we have temporal differences, some equations for understanding that, and updating the Bellman equation based on that as temporal differences to run our agent. So if you are interested in, you can, we have the last semester classes videos too. You can have a look there in details. I later a little bit explain it, some specific parts that is not, I didn't cover, but not too much in this course. So for your knowledge, AlphaGo and AlphaGo 0 are the most kind of initiating part of reinforcement learning that introduced by DeepMind, and in March 2016, not too old, reinforcement learning bet Leo Sodal in 5-game match that you can watch the video if you haven't. That's very interesting documentary, just is like 1 hour, that shows how for first time a machine can beat a human. That is like stunning. And this guy at the beginning says, oh, I'm gonna beat it, no worries. I came here to defend human rights, no worries, I'm gonna beat easily. So he loses the first game, and he says, no way, I'm gonna beat second round, no worry, that's okay, I did a mistake. Again, he loses. I think in third he wins, or fourth he wins, but finally he says, oh, I'm sorry, I feel very regret for human race now. So that's very funny. So I highly recommend to dedicate time to watch it, because this is kind of revolution at the time that human lose game against machine for first time. And that's the game. What we have as important things here, we have the environment. We need to answer what is the environment, what is the agent, what is the state, what is the action, what is the reward. The state, action are also important here in machine learning. We will discuss it. But the other parts are going specifically to reinforcement learning. For example, here board and player is environment. Agent is a player that plays the game. The state is the board configuration. Nothing is important, not important. Everything that is important is the board. The action placing a stone, and reward is like winning or losing or current evaluation of the board that we are into. And we have 4 important elements. Again, I'm not going to explain them in details, just to who doesn't know about reinforcement learning. We have a policy. A policy means the kind of a knowledge that we say how to do action. In this situation, I'm doing decision, right? I'm going forward. So this is my policy says do the action. Going left, because this guy is obstacle for me. Go forward. So this is my policy that says how to interact in the environment. So whole reinforcement learning idea is learning policy. So we want to train algorithms to learn policy to act in the environment. We discussed one semester 16 lessons of how algorithms can solve this. If you are interested, you can have a look at previous semester course. We have reward signal per each action that agent does, something happening from the environment. If I give candy to this guy will be happy and say thank you, then that's reward for me. And if you study well, you get high mark, then that's reward for you. I will be happy, you will be happy, your family will be happy, then you get reward. Whatever it is, we should define reward signal based on what's happening, then we define it. You have industrial arm, picks an object. If it's successful, you say, yeah, good job. Then that's reward signal. On the other hand, we have value function. That value function is different from reward and says the evaluation of the situation that can contain long-term look. Not just, if I give candy to this guy, every second one, is it good? If you look at short term, yeah, this is good. He gets lots of candy. But if he eats it, he gets sick. In long term, is not good. So the value function says, okay, we need to evaluate situation based on many perspectives, not only that reward that you're getting long time. Another example of the robotics, if I go to the corner, want to go to the corner, if this path is blocked or here is blocked, if I want to go toward that only, then I cannot never reach that one. I need to allow some not getting reward to find another path to go there. So this is called the value function that should be useful over there and helpful over there. And finally, we have model of the environment, that in model of the environment, we have transition probability or not. It means that I know the environment, how it interacts or not. And based on that, we have two different branches of algorithms. It means that, like, I know probability of if I'm here, I go to right or no, and which action I choose. If I know the probabilities in the environment based on my agent, I have the model of environment, or I don't have. That is called model-based and model-free techniques. That there are different branches that can be discussed. We discussed already. Some environment you have, like, for example, one industrial arm should do very specific tasks, and you know the probability. Then if you know probability, you have right algorithm that works better. But if you don't know, environment is dynamic, you don't know anything about what's gonna happen, like real life, then you don't have. And the algorithm goes to class of model free, then we have a bunch of algorithms over there. I'm not going more in detail. If you are interested, you can ask questions. For example, here you can see the robot that needs to learn how to pick different objects and do some actions, how to successfully grasp it. At the beginning, tries wrongly a lot, wrong, not success, but finally learns. Based on the reward value and the algorithm that we define here, we have object as robot as environment, the agent is robot itself, the state of the environment. State means that so if I freeze the time and no one moves, we can call it as one state. So next state can be 1 second later or 1 millisecond later, or somebody moves a little bit. So this can be a lot, right? So that's what's called state. Whole of that can be called the state space. So in each state, in each moment of time, what your agent needs to do then is related to the action based on this state. So kind of I'm reviewing for who guys studied reinforcement learning already to make it more robust. So what is the action? Robot arm movement. We can define it in different forms, discrete, continuous. And what is the reward based on what we want to do? If you only want to grasp, we say, okay, grasping is reward. Or if you want to grasp only red ones, then grasping red ones is reward. Then green ones, we give punishment to robot. And reward and punishment is not candy, it's like some values, simply. In equations that we calculate for robot brain, and it is come from the Bellman equation. So we say reinforcement learning says what to do and how map each state to action. And learner is not told what to do. Learns and discovers itself. And not only I may do something now that maybe affects my 10 years later. If I do something good now, 10 years later I may be in better situation or worse situation. Then I say, God, why you did it to me? That's yourself. That 10 years ago, 5 years ago, you didn't study, then your work is terrible. Your salary is low. You're fighting with your husband, wife, because of that salary. Because you sleep in my class here. With machine learning, you can earn lots of money in the world now, right? I think the highest work with highest salary is machine learning, correct? So 10 years later, if you fight with your wife or husband, then remember me. Okay, so I think let's have like 5-minute break. Then we continue with much more applications of machine learning. There are a couple of interesting things we need to discuss. Then that's it. So just 5-minute break. If you want to rest a little bit, you can do. Okay. Okay, for today, let's continue a couple of, we have like 6-7 more slides. Let's finish it. We discussed about general applications, supervised, unsupervised learning. We want to now specifically see the latest remarkable advances in machine learning. Although we saw some examples, specific applications, but we want to a little bit have a bigger view of the remarkable advances. One is transfer learning. That with transfer learning, I will discuss how we can use same training information, the weights to another training, so that it makes it faster for something new. We will discuss it. We have generative adversarial networks, GANs, as one of the latest remarkable advances. We have multitask learning, and we have also the explainability and interpretability of the model. So you may never hear about this, but we will discuss what is it. This is very important because our models are going to be very, very, very complex. And that's not good always. We will see it's a little bit problematic. Although your network gives you very good solution and everything works perfectly, but we will see why that's not sometimes good, and we will discuss it. And also reinforcement learning, as I explained. So in transfer learning, what we say? In transfer learning, we say we want to have a technique that where pre-trained machine learning model can be adapted to new network. So that we want to solve, like we already solved problem for image processing very well, for object detection. Now we want to solve NLP problem. Can we use the knowledge that something that we learned from that data to new data? Is it possible? Can we use it? The experiment shows, and the answer says, yes, you can. Instead of learning everything from scratch for your problem, you can learn from some other models that learn something totally different. You may think, well, that's like totally different problem. How can that help me? But the experiment shows if you do good adjustments, yeah, it can be very, very helpful instead of learning from zero. So especially if the problem is similar, that of course should work. But if the problem is not similar, still there are some general rules that general rules can be helpful to train new data. So applications of transfer learning is computer vision. For example, in image classification, object detection, and segmentation can be used. In NLP, sentiment analysis, recognition, and machine translation can be used, and of course it can switch also between all these that I'm explaining to you. For speech recognition, that we want to identify the who is talking to us. In robotics tasks, for reinforcement learning and control tasks. For example, in reinforcement learning control tasks, if you have knowledge, you can think that how the computer vision training network can help me for reinforcement learning. Is it possible? So when your agent is trying to learn policy from action, can I adopt transfer learning with computer vision or neural network to learn something faster as policy in my agent? Can I design a model like that? This becomes nice research. And even with this, you can define your PhD thesis. Then, so this is the transfer learning. Second one is GANs, a popular deep learning algorithm for generating new data, similar to data set that we have, but not limited to be very similar. So the applications, later we will discuss it more in details. We say the applications are like image synthesis that says, okay, we want to generate entirely new image based on some image that I trained my network, and I want to create a novel photo that is realistic image too. It's kind of like drawing. You have an artist and you show many samples and you say, okay, I want this now. Can you draw for me? GAN can do that. How? Later we will see, kind of, as much as we can go in deep. So text generation, GAN can also generate text. What is working in GPT is also something similar. Audio generation, you've seen maybe Barack Obama videos that he's talking with fake AI. I didn't bring it here, but you can consider something similar that can generate your voice, what you're saying, having your data set. Because of that, you cannot rely on too many, now you cannot rely on the videos and the things that you're seeing. Although now they are not 100% accurate. If you are very smart or specialist, you can understand. But after some time, it will be very difficult. So another fifth application, image-to-image translation. So you have image, you want to translate it. I put a picture here that you can see how stunning it is. So the horse and zebra. You can give this and say, I want the zebra. Gives you back the zebra one. And you give that, you want the horse back. Doesn't matter. The GANs do that for you, and that's very interesting. So, and it, of course, is not limited to that. Anomaly detection is another application that says identify the instances in data set that causes anomaly and, for example, fraud detection in data sets and data that we have. GANs can be used over there. These are just like simple introduction applications. Data augmentation, it means that it's very important in machine learning. Data augmentation means that you have limited number of data sets. As the problem that we stated, with GANs, you can generate new data. You can generate new medical images. You can generate a similar data that helps you training. It says, okay, so I'm taking a picture of this object from this view, and I have like only two. Can I generate like from other sides, from different perspective rotation? Yeah, GANs can help us to do that. Rescale, change the light, change the size, distort it, and whatever we want to do, we can train our network to do that for us. So that's second. Third breaststroke or interesting task is the multitask learning. It's a little bit challenging. Still lots of research can be done here. So, and nowadays going on much more under interest, we say multitask learning is a technique that single machine learning model is trained to multiple tasks simultaneously. It means that I have a network, not only can detect object in the image, but also can recognize the voice that is coming, recognize what is happening in the environment. Those are totally different inputs. But the multitask training is like one single network, one single machine learning can do job together. Can we train it? If we can train it, what happens? At the beginning, maybe we can train 2. Then if we can train 5 together, what happens? Then we can say at the end is like something like human brain, right? Can analyze everything with one network and everything comes and connects together. So far, we are splitting everything. We separately discuss about the image processing, the video processing, or whatever it is, and we're separating with NLP, and later we try to connect them together. But in reality, it's not like that. If I drop this object, I see that it's dropping, and also I hear it dropped. So the combination of these are more meaningful. That is coming to multitask learning. So we want to improve the performance by doing this multitask learning, learning the knowledge together. And of course, we try to reduce the data and the computation requirements at the same time, because if we have like 5 tasks, we need 5 different models. learning models, 5 different outputs for that, but if we combine them, maybe 2 times bigger than, like maybe 50% will be less big, but it still can do the multitask applications. So do we have example, or is it like science fiction? So of course we do. One of the examples is between NLP and computer vision, and we have the UniLV, that is unified language and vision pre-training model that can do these together. Of course, it is not as good as so far each independent algorithm that we have for, but this model can train both together. That's very interesting. So if you have time at the end of class, in the end of this semester, the state-of-the-art algorithms, we will try to cover such techniques. And I may ask you also to find out some papers as homework and study what is it, and maybe discuss it together. So what they are doing, the general idea over there is using a unified encoder. They try to encode data together, so that I want to give you the clue to think about it, that the encoder, what is the encoder? Encoder means that your information is coming. With encoder, you're reducing the dimension. So if you can find a way that the reduced dimension from image and NLP, natural language process, ends up with something similar as encoder, then you can interpret it easily, right? So that's the general motivation and idea that you can think about it. And later, of course, we can discuss it. For multitasking learning, there are more applications: NLP, computer vision, speech recognition, healthcare. For healthcare, for example, disease diagnosis, treatment recommendations, as recommender system can be done. So not only like in healthcare, for example, can be a combination of NLP, computer vision, healthcare to do the treatment. For recommender systems, specifically for user behavior recommendation, based on who was one of the students who are working on reinforcement learning based on that, and robotics, of course. So if your robot can learn multiple tasks together, not only grasping, but also playing tennis, isn't it good? And playing chess, 3 tasks together. So that's, of course, nicer. And that's called multitask learning. And of course, it gets more difficult. But we are here to solve difficult problems as machine learning researchers. Another important topic that comes when the model becomes more complex is the explainability and interpretability. So that we say, okay, we need to understand somehow, when we have a model, how the decision-making process is happening. We need to understand it, right? What does it mean? It means that you have model, you train and it works perfect, but that's too big, and you don't understand what is happening inside as developer yourself. Then what happens? Think about it. So if you have neural network with big size, a couple of layers, that's fine. But when the model becomes very complex, we will see some, then there is a need for having some other techniques that explain my technique to myself. So we train another network to learn how this network is working, to explain it to my language in simplest form so that I can debug it, so I can understand what is happening, how the connections are. That's why I'm saying the explainability in machine learning is also a new topic and will be a hot topic soon, and there will be lots of research. And there are some research that also we will see. Now you see, you download, you go to, for example, see some networks, you download the code. It's like too big, for example, in simplest form code. To understand it, maybe 2 weeks you need to read different parts, different components, how it's happening. in simplest form, if there is some other learning machine that explains the code for you simply, this can be one of your research, to train some model to explain the codes and find the connection between functions and explain you these variables are important, these functions are important. And there are some models, there are some even built-in techniques in programming languages, but here, if in that code you have training and artificial intelligence machine learning models too, then if it can explain that to you too, then this is very also marketing application that you can work on it and sell it. This is way to be rich. So as like me also, I like to, if there is example of like big model, then I can run another code and then reads the code and explains the model connections and says how it's training and everything. This is what we can do over here. So understanding the individual features that influencing on prediction, because we want to do prediction in machine learning, right? In simplest form, I set the size and price of phone. We extend it to more complex ones later. And what else we have? We have, for example, one example. Do we have any technique that is working? Yeah, of course we have LIME, local interpretable model, agnostic explanation model that can provide human understandable explanation of the specific prediction model that we have. So how it is doing? It is doing with interpreting and explaining the prediction of the machine learning model regardless of their type or complexity. Doesn't care about what type of the model it is and the complexity it is. It is kind of general that you give the model and they give the algorithm and explains to you what is happening in your own language. It has been used to explain the predictions of the wide range of deep learning models, like you can use it for convolutional neural networks, recurrent neural networks, and deep belief networks for unsupervised learning. Is that like deep belief networks later we discuss is specifically for unsupervised learning techniques. And now you should think unsupervised learning was clustering, and we wanted to do what? Find the pattern in the model. So you should like quickly load this to your mind and later on quickly interchangeably we'll use it. As last topic, now we increase the difficultness, we go back down now, we want to start to see what is happening from especially next class. So we first start to talk about regression in simplest form. We say it's a method to find a relationship between different variables, independent variables, like you can think about the size and price. It can work on dependent variables on features, and it's a type of supervised learning method that we will see how it is working. We basically use regression for prediction, time series modeling, and extracting relationship between two variables, and show that we can plot a simple prediction that we've seen, like we have data. In simplest form, we will see that we want to draw this line, and predict the data in simplest form. And how we can formally do that, we will see. Then we start to extend it to more complex, up to reach and even to the multitask training. That is the most complex of that one then. So today we discussed the machine learning concepts, we discussed the history of the machine learning, we discussed the supervised, unsupervised, reinforcement learning, and semi-supervised learning topics. We understood the differences almost. We know now generally what they are looking like. We mentioned the latest general advances of the machine learning and the open problems almost. I discussed it, and thank you very much. If you have any question, feel free to ask. Otherwise, this brings us to the end of today's course. No question? Okay, thank you. I dismiss the class.